IP addressing, IPv4, IPv6. We got two versions. IP and IPv6, they are basically the protocol itself. And for the protocol to identify a device, the device can be a firewall or a router or a server or a PC or an IP camera. The protocol uses certain pattern like this. 32-bit is written into four decimal number separated by three decimal dots, three periods. IPv4 version 4 has been for a while. We never seen IPv3 or IPv2 or IPv1. It was IPv4 when everyone know networking, internet. IPv4 has been for a while and it's going to be for a while. IPv6 is also an interesting topic, which is 128-bit size that is also used to identify a device. But the address structure is not the same. So we will not be focusing on IPv6 now. Let us focus on IPv4. IPv6 later days we will see. Now, this 32 binary bit, binary we know it will be 0 and 1, 0, 1, 0, 1, 1, 1, 1, 0, 0. It is very difficult to memorize or handle this type of number. So what they did is the 32-bit they converted into decimal. But again, if it is a big number, one single big number, it will be again difficult to use it properly, manage it proper. So what they did is they did some grouping of 8 bits, like 32-bit is grouped into 4 groups, each group of 8 bits, equally divided, 8 bit, 8 bit. So what is the advantage when you group like this? You can provide some portion of this for networking, and the remaining we can use for the device identification. Because in an internet or in a network, the device need to be identified. So first of all, network need to be identified because there are many networks. My company is one network, your company is another network. The intermediate ISPs are another network. So they all need to be identified first, and then in that network, which computer that is necessary. So two things, like you need to know the street name, and in the street name you need to know the house name to go to a person's house. So the 32-bit number is broken down into 4 groups, 8 bits, which helps to classify into 4 classes: class B, class C, and we also got class D. So what is special in class A is only the first octet will be pointing towards the network, will be used for identifying the network. Whereas the other classes are not same. The other classes are like this. The first 2 octet, if it is network, then it is class B, and all the other are host. See, there's a big difference here. Here only 8 bit. Here we got 16 bit to identify network, and we got 24 bit to identify the host. Here you got 16 bit to identify the host. Now again, there is another variation. We got class C, with first 3 octets of network, which is nothing but 24-bit of network, 8 plus 8 plus 8, and the last 8-bit is what given for the host. So if you don't break down that 32-bit into these groups, into 4 groups, this is not possible. This classification won't be possible. So that's one reason why it is classified, why it is broken down. The first reason is to classify. Now, why should we classify? Why should we classify? See, because the network users are not of same size. Some are small size. They need only 8-bit to identify their host. Some are medium size. They need less than or equal to 16-bit. And some are very large network companies. They need 24-bit or a little less than that. So anything between 17 to 24-bit needed company will hold a class A address. Anywhere between 9 to 16, they will hold a class C address. Yeah. I mean 16-bit, 9-bit to 16-bit. And here from 1-bit to 8-bit, if anyone wants, these are all bits, okay? Bits. I'm just, if a company needs less than 8-bit, why they will go for class B? They will go only with class C, isn't it? Let me repeat. If a company needs, that depends on the number of IP address needed. See, I'll talk about that in a few minutes. If number of IP address that they want can be obtained just by using 8-bit, then they need only class C. The number of IP address they need, if it is not sufficient with 8-bit, then they will go with class B. If someone wants like 70,000 IP address, then definitely they need class class A, 70,000, because with one class B address you can have 65534 address, 2 to the power of 16 minus 2. So what I'm trying to say here is, according to the user group size, A, B, or C is determined. A, B, or C is determined. Now, next is class. Correct, because of subnetting. We have not gone to that level now. Let us simply talk about these classes now, then we'll go to classless. What you are talking is classless. Today we have everywhere classless. But without knowing this thing proper, understanding classless will be difficult. So, now, class D, if you see, class D, we don't have network or a single host. In order to identify group of device, group of device, regardless of in which network they are. If you want to identify a group of devices, I don't care which group they belong, which network they belong to. I want to identify one guy from London, one guy from Nigeria, one guy from Tanzania, one guy from Kanyakumari, one guy from Noida, one guy from Shanghai, one person from Malaysia, one person from Australia, Sydney. So to identify all these guys, around 10 members who are in different part of the world, I need an address. This is not one person address, it's a group of persons. My employees are sitting all 10 locations. And when I want to send something, hi guys, let's start this project. I want all these 10 people to receive my message. So they need to be identified with one address. 10 people need to be identified with one address, which is what called as multicast address. So multicast address is class D. Class D is only for multicasting. So that we will not see now, we will see later, much later. Now our focus is on A, B, and C. As we know, in A, there is only 8-bit for network. If there is 8-bit for network, we say 8-bit is already given for network by typing this as the subnet mask. Why should I type 255 to say 8-bit is networking? If I have 10.0.0.1, I don't know which part is network because today we already started subnetting. But when you see an IP address, we will not be sure whether it is class A or B or C, or 8-bit is given for network, or 16-bit is given for network. We will not be sure unless you see the subnet mask. If I see 255.0.0.0, then I know this is class A address, only 8-bit. But when I see something like this, then this is not class B or C, this is subnetted address. This is not a class A or B or C. This is subnetted network.
It means like, but is the IP address is a class B address?
No. If you see this IP address number 10, then it will look like class A, because only for class A the range will be 1 to 127. Class B, the range is 128 to 191. See, this 10 is here, correct? It looks like class A, but the subnet mask looks like class B. This is neither class A nor class B nor class C because it is subnetted. You should not call it as A or B or C now.
But earlier you told class A, B, and C.
See, if your IP address is like this, see, only 8-bit network, then it is class A. But here, it is not 8-bit network, it is 16-bit network. Here, 10 is the network. But here, 10.0 is the network. This is another network. This is not same. Because this 8-bit is also now considered as network. So this is 10.0 network, this is simply 10 network. They are not same. Yeah. So now class C range is 192 to 223. Right? This range, how did we get? We need to discuss. What I'm going to say now is not that important, but it's good to know, once for a lifetime we can learn. How is that range, class A, is 1 to 127. See, it's not a round number. And class B, if you see, it's 128 to 191. What is this? 191. Why not 200? And class C, if you see, 192 to 223. Again, it is not a complete number. 223. Do you have an answer for this? Do you know anything like how they got this?
Class A might be 2 raised to 8. 2 to the power of 8.
2 to the power of 8 is 255. That's the whole bit, whole octet.
Okay. I don't know.
You don't have any idea?
No, I don't have. Maybe I forgot.
Okay, no problem. You see, the first octet in class A or B or C, if you see, the first octet is always what? Network. There is no change in that, right?
Yeah.
But in class B, you have network. In class A, you don't have network. But this first octet is same for all three, right?
Yeah.
Okay. What they did is, in the first octet, they did some change to derive this. I'm asking you a question. If I have 192.168.1.1, what class it is?
192 should be class C.
Okay, so you are not seeing this number. If you would have seen this number, then you would have said class B. You are not seeing this number or this number or this number. You decide only based on the first octet, isn't it? Okay. Which means to derive this, they have done changes only in the first octet. Sorry. So 2, 3, 4, 5, 6, 7, 8. How many bits are in an octet? 8 bits, isn't it? Now, I told you they have done some changes in the first octet in all class A, B, and C. What change is that? This is the change. This one and this one. And here. Sorry. This is the change. This is the change. This is the change. Now I'll explain you what it is. The first bit is always 0. Here the first bit is always 1 and second bit is always 0. And the first bit is always 1, second bit is always 1, third bit is always 0. They made this as these bits as constant, meaning you cannot change this. You cannot change that 0 to 1, and you cannot change this 1 to 0, cannot be changed. Right? So they made this as constant. That is how they derived it. That's how they derived it. How? By fixing that number 0 and 1 0 and 1 1 0, how can they get it?
So that range 1 to 127.
Mm-hmm.
That can be, for example, for class A, 1 to
Mm-hmm.
127, right? So which is not there. So only 7 is there. So 7
Correct. You, you got it. Now you see, when we have 8 bit, 1, 2, 3, 4, 5, 6, 7, 8, 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 6, 2 raised to 7. So anything raised to 0 is 1 only. This is 2, 4. It will keep doubling. 8, 16, 32, 64, 128. Now, You see, if all these bits are 0, is there any value? No value. No value. So the minimum, if you see, putting this bit 1 is the minimum. That's how you got this. And the maximum you can do is this.
all one. Yes.
Now, if all are 1, what will be the total? See, this is always 0. When all these are 1, what is the value? For that, you see, we are saying all these are 1, isn't it?
Correct.
You know how, what is the sum of all this? Sum of all this is 127. For that, you no need to add. You no need to really add. You see the next number. 1 less is what? The sum of all this. Always 1 less. Okay, so it's 127. Likewise, if you see this one, if these bits are 0, is there any value? Yes, because this is on.
1. Yeah.
What is the value of this place? 128. Correct now. And then the maximum you can do is this one. Make all this 1. Now what is the answer for this? If all are 1, you will get 255. If all are 1, you will get 255. And this one you need to subtract. What is the value of that?
2 raised to 6.
What is the value of that? 64, no?
64.
That's it, 191. Correct, no?
Yeah.
Next. If all these are 0 bits, is there a value? Of course there is a value. These two are on. 128 plus 64 is 192. And all these, this is constant. You cannot change it to 0. And when you add all these bits, 255 minus, what is the value of this place?
32.
32. What do you get? 223. Likewise, even for multicasting, they did the same. Class D, if you see, the range is 224 to 239. How they got, you know? I'll show you.
Class D, right? Class D.
Multicast. Yeah. In multicasting, how they got that? Let us see. In multicasting, how they got that? Here 0, here 10, here 110. What is your guess? This will be triple 10. Yeah. Now, if all these are 0, is there any value? Yes.
Yeah.
What is the sum of this? 224. See, 192 plus 64 plus 32. Yeah. 3 bits, right? 192 plus 64 plus 32, which is 224. And what is the maximum? Make all this on. So 255 minus, this is 16. What do you get?
230.
That's it. This is how they derived the range. Is this really important to know? Not really. But we should know that there is a logic. Without logic, so they did not simply come to the number, they have a logic. Fine. But what is important is this range number we need to memorize. We need to know without referring. Because when someone says, we did not do subnetting, and what is this? Address. I should know that it is class B. How I know it is class B? Because I know the range. If I don't know this range, then I cannot command. Now, by looking into an IP address, you can definitely say class A or B or C if they have not subnetted. For that, you need to know the range. Okay, next. What is subnet mask? As we all know, in class A, the first octet is networking. So when you turn on all the networking and add the value, you get 255, isn't it? For class A, only first 8-bit, no? Now, first 8-bit, you add all the face value, what do you get? 255. Now, what is subnetting? What is subnet mask? Subnet mask defines how many bits in the above address is given for networking. What is the network? 15. What is the host? 1.1.1.1. 15th network, 111 is the IP. This is the default subnet mask. Because why we call this default? Because someone may do subnetting also. In that case, the subnet mask will not be like this. It will be more than 2550. It will not be 255000. It will be bigger than that if they subnet. Can they subnet lower than this? No, they won't do it. They cannot do it. Minimum is 8. See, 15, minimum is 8, isn't it? Can you go lower than 255? Not possible. Not possible. You understand? Do you have subnet mask like this to 0.100.0.0.0? No. I don't know why you are silent. Listen. For class A, 8-bit is minimum. Correct? Not okay. 8-bit is minimum bits for networking, isn't it? Can you go lower than this 8-bit? No. Because class A means 8-bit. So you will never see 200 or 150. It will be always 255000. That's why it is called as default subnet mask. Now, what will be the default subnet mask for class B? Let's say you got 183.0.0.0. What class is this? Correct. If this is class B, what is the network? 183. What is the network? Exactly. So these two octets are network. So subnet mask is 255.255.0.0. So this only says this. Because of this, you are saying 183.0 as a network. So what is subnet mask? Subnet mask defines how many bits given for network. 16-bit, that's why you put 255. Now, 200.1.1.1. What's the subnet mask for this? 255, 255, 255.0. So what is the network? 200.1.1 is the network. .1 is the host, isn't it? So the default subnet mask for class A is this, for class B is this, and for class C is this. All right. Now let us go and. Are you comfortable with so far what I have said?
Yeah. So,
Okay.
sir, one doubt. So, even if you're saying default, can we change that?
That is, you cannot go less than that. You can go more than that. That is what called a subnetting. We'll see that later. Subnetting.
Sure, sure. That was fine. Yeah. We can proceed.
As I said, you cannot go less than the default. You can go more than default.
Okay.
Now, can you say the class A range? What is the class A range which we saw just now? You don't remember?
Yeah. 1 to 127.
Correct. But we don't use 127. You will never see an IP address assigned to a device with 127. You will only see up to 126. Why is it? For you, I can show you a live example. Wait a minute. I'll try to give an IP address with 127. You see what really happens. Oh, la, 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 la. Now I'm giving to a loopback interface. You see, NPK network packet capture adapter. Okay. Manual IPv4. You see, I'm going to give IP address starting with 127 dot. It should not accept it. Let me see. At least when I submit, it should not accept.
It is 127.0.0.1 in local host address, no?
I'm coming there. Wait. Now, when I save, it should throw. Oh, okay. Cannot save IP address. Check one or more settings. Try it. Okay. Oh no. Actually, I am not comfortable with this operating system version. Okay. Let me do this. Okay. Now I can show you very well. For one of the VM, I'm trying to give that IP address. While typing itself, it will show you error. That's what I want to show you. You see, I'm going to say 127. That's all. You see what it says?
Back address. So, okay. We specify some other value between 1 and 226.
So you cannot use numbers starting with 125. Sorry, 127 because it is reserved for loop back address. That is what I want to say. 127 is called as loop back address. So 127 is the first octet, but there are three more octets, no? In three more octet, how many bits are there? 24 bits, isn't it? 8 plus 8 plus 8. With 24 bit, how many IP addresses you can get? 2 to the power of 24 minus 2. I'll talk about minus 2 later. So that will be lakhs of IP address. That will be lakhs of IP address. Now, are we going to have lakhs of IP address for one purpose called loopback? Wow.
Not good, no?
Correct. But early days, they did not realize that they are doing this mistake. They said simply 127, not a valid IP address. That is reserved for loopback. They wasted. That is the reason why if you go now to command prompt, ping 127, any number you say, I'll type
10
10,
dot 20 dot
20 dot
25.
25. I'm going to get a reply
How come?
because the entire 127 they have given for what?
Loop
Lubeck.
back.
See,
But there is no such
that is
uh,
see. No. You're confused with Lubeck address and Lubeck interface. Please focus.
okay.
Lubeck interface is a logical interface which we will have on routers that we'll see later, and that is different. That is interface. That loopback interface will not have 127 address. Even there, if you try to give this loopback address, it won't accept.
Got it.
Loopback interface also won't accept this address. Loopback interface is a virtual interface. That's all. Now, what is this loopback address? Okay. If you want to check whether someone hear your voice, what you will say now after saying hello, you will wait for them to say hello, isn't it? If they don't say hello, you will keep on saying hello, hello, hello. You will not say anything other than hello until they say hello, isn't it? That is what looping back. I'm saying hello, and if I hear hello from them, which means they already heard my hello. When I say hello, he says, hi, how are you? That's what loop back. It's an acknowledgement coming to my hello. Or if he's a new person, he will say, hello, who is this? When I say hello, for example, you are saying hello to me, and what I'll say, if I'm hearing, hello, who is this? Because we have never spoken before. This is the first time you're calling and you are saying hello, and I am also going to say, hello, who is this? But if you're a known person, I would have said, hi, how are you? Yeah, but that is what connecting back. Is that the matter that we were trying to talk now? We want to talk something else, but we want to check the connectivity. That is what loop back address. Checking connectivity. Checking connectivity with which computer? No other computer. To ourselves. That is what looping back. I'm going to send a packet and I'm going to receive a reply for that. Why I'm doing that? I'm checking the connectivity. With whom I'm checking? From application layer to physical layer. Back from physical layer to application layer. If your operating system is fine with all the networking feature, and if the driver for the NIC card or Wi-Fi is properly configured in your laptop, only then you will get this reply. Otherwise, you won't get this. For example, your NIC card, network interface card, driver is missing, assume. This reply will not come. So, just we are checking whether our device is eligible to become the part of networking. All right. Okay. So for that, simply this address is more than enough, but unfortunately, they did not realize that we are wasting, and they have given all 24-bit. See, I'm simply randomly typing some number. I'm able to get reply from that number. Because the operating system in my laptop is designed to reply me back with the same address which I'm pinging. That is what called as loopback address. Who is responding me? My own operating system. Do we have this IP address on any of the interface? No. So they have wasted lots of address, lakhs of address. Okay, next is in class B also one address you cannot use. In class A 127 you cannot use, isn't it? In class B also 169.254.x.x. This can be any number, but first two octet 169.254 you cannot assign to a computer. Let me try showing you that, and then I'll explain you why. You see, I will go and try to give that IP address first. 169.25.0.1. Okay, this guy is accepting, but this is not a valid IP address. Why it is not a valid IP address? You should not first of all assign this. Why it is not a valid IP address? See, this address is called as Automatic Private Internet Protocol Address, APIPA. Automatic means this address need to be automatically assigned as the IP address, and it is used privately. Automatic Private Internet Protocol Address. That is why wait, I'm coming there. But I'm trying to make you memorize this word APIPA. Automatically assigned IP address which is used privately. Automatic Private Internet Protocol Address. I think this you will understand. Internet Protocol Address. You will only forget about this automatic private. Okay. That is the reason why I said you should not assign. It should be assigned automatically. Now, when this address need to be assigned automatically, or in another word, why do we need this address? What is the purpose of this address? Is what we need to know. See, to my computer, when I am having IP address 10.0.0.0, why this need to be assigned automatically? Actually speaking, if you already have 10.0.0.1 as an IP address, this address will never be assigned automatically. Then when this address will be assigned, and what is the meaning of this address? Why it is dynamically assigned? For example, you're asking, do you have coffee? In case if they don't have coffee, they should say, I have tea. Automatically, they give you a solution. Okay, let us not go into that one. Let me come straight to the point. You have a computer. This computer will ask for an IP address. To whom, DHCP server. What is the job of DHCP server? Is to provide an IP address. Before providing, it will take the MAC address of the computer, and then it will give IP address to the computers. So we will be calling this as client then, DHCP client, because they receive IP address from the server. Okay, now client is receiving IP address. Server is giving, what if this wire got disconnected? Then who will give you IP address? Or what if the server is running out of IP address? The server is designed to give only 24 IP address, but you added the 26th computer or 25th computer.
Yeah.
Then the IP address cannot be given, right? In that situation, when DHCP is unreachable, when DHCP server is unreachable for the client, or when DHCP server is not responding for some reason, like IP address is no more available, something like that. In such situation, this client will wait. After waiting some time, it will automatically generate this address 169.254.1.1, something like that. What is the purpose of this address? Number one, it is telling you that I am not receiving IP address from the DHCP server. That's the very important message that this number conveys. 169.254. As soon as you see that as an IP address of any computer, don't be silent. This is not the genuine IP address. This is automatically assigned IP address because of DHCP server missing. So what is APIPA? APIPA is an address which is dynamically assigned when a client is looking for an IP address from a server, but server is unable to provide. When server is unable to provide, an address is automatically generated. That address is what called as APIPA. That is simply not for communication. That is simply to say that DHCP server you need to troubleshoot. That's the second point. First point is it says I'm not getting IP address. Second point is DHCP is having an issue. So if you fix the DHCP server, your problem is solved. You will get a valid IP address from the DHCP server. So this is just
Yeah. Once
we are not assigning. We are not assigning. Operating system is going to assign. It will get the original DHCP server address. This will go away. Yeah. Right. Did you understand, Apipa? Now, last topic of the day is this. We have some address to be called as private range 10.0.0.0 to 10.255.255.255, and next is 172.16.0.0 to 172.31. You see, here it is 16, it's 31. 31.255.255, and then 192.168.0.02, 192.168. Focus here, the third octet, 255.255. So this range of IP address you will not see in the public cloud. In the internet, you will not find this. The purpose of this is to be utilized within the office, within an enterprises, locally within an office, within an enterprises. You will not be able to route any packet with this as the source address and destination address. This address cannot be used for communication outside your network. Inside your network, you may use one of this address range, and for this address, you don't need to pay anyone, it's free. But if you are using private address inside, you will be able to communicate. If you try to use it outside, not possible. You don't communicate. Hmm. No one in the internet will be using an address starting with this range. It's only for within the organization communicate. To communicate within an organization. Google also within the organization they will use this. But when they are trying to talk to outside, they will get natted to a public IP address. Private IP addresses. Private. Private range of IP address. Other than this, all are public. Yeah. Other than this, all other addresses are public. All right. You stop